All right, let's do a little bit of review. Solve triangle ABC. That means we need to find all the sides and all the angles. Angles are somewhat easy. I'm going to do 180 minus 33 minus 90 is 57. So we have 57 degrees right here. Yes, you can do that much easier, but just by doing 90 minus 33, but whatever, it's all right. I've got all three angles. Now I'm going to use sine, cosine, or tangent. So TOA. So sine is opposite over, or sorry, tangent is opposite over adjacent. So opposite over adjacent, I can say tangent of 33 is A over 17. Multiply both sides by 17. Not sure if my calculator's in degrees or radians. Definitely not that. Let me change it. Sorry. Okay, so A is 11.0. And then I can do adjacent over hypotenuse. That's cosine of 33 is adjacent over hypotenuse. So I'm going to multiply by C. I can multiply by C and then divide both sides by cosine 33. So 17 divided by cosine 33 gives me C as 20.3. You can check that with the Pythagorean theorem, or you could have used the Pythagorean theorem to solve a few of those. All right, solve triangle ABC with those measurements. I'm just going to draw a triangle so I know what I'm looking at. A, B, C. C is 90. B is 41. 90 minus 41 is 49. 90 minus 41 is 49. Across from A is A, across from B is B, across from C is C. We know that C is 22. That's hypotenuse, so I can use sine or cosine. Let's do sine first. Sine of 49 is opposite over hypotenuse, A over 22. So multiply both sides by 22. 22 times sine 49 is 16.6. And then I can use the Pythagorean theorem. A squared plus B squared equals C squared. 22 squared minus 16.6 squared. Square root of that answer. I get B is 14.4. All right, today we're learning about the law of sines. I actually teach about this in our geometry curriculum, but we're going to assume that you didn't learn it in your geometry curriculum, so we're just going to learn it all now. So the law of sines says that it can be used to solve right triangles when two angles and the length of any side are known, either angle side or side angle cases, or when the lengths of two sides and an angle opposite of one of the two sides are known, which is the side angle case, which, remember, this case never works for congruency, because if it spells a bad word, even if it's backwards, you can never use it to prove congruency between two triangles. So the law of sines states we can find the any of the unknowns by setting up any two of these ratios for sine A, if we know angle A, angle B, or angle C. We don't need to know everything, we just need to know two sets of the ratios. So we would say that sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. I can take this one is equal to that one. I can say this one's equal to that one. It doesn't matter. I can say this one's equal to that one. Any two of those ratios work. Or you can do the inverse of it. So let's jump on in and try one. Solve triangle ABC with angle C equals 170 degrees, angle B equals 25, and side B equals 15. So I don't know anything about A, so I'm not going to use A right now. I can say that, change my color, sine C over C equals sine B over B. And I can solve for the unknown. So sine of 107 over C equals sine of 25 over 15. Cross multiply. C times sine 25 equals 15 times sine 107. Divide both sides. I'm not going to show all these steps every time. You guys should know how to solve for a variable by now. 15 times sine 107 divide by sine 25. I get side C as 33.9. Cool. Now I know if I have these two angles, I can figure out angle A. So 180 minus 107 minus 25, because the interior of a triangle always equals 180, 48 degrees. So I can say sine of 48 over A equals, and let's just use B since we know those, sine of 25 over 15. Cross multiply. 15 times sine 48 equals A times sine 25. Solve for A by dividing both sides by sine 25. 15 sine 48 divided by sine 25. A is 26.4. So it's not too difficult. Grab any of the ratios you know and go ahead and solve for them. Go ahead and try these on your own. I'm going to work them and show the answers, but if you could try them on your own and see if you can get it, that'd be great. I need to draw a triangle first because I can't picture all that stuff in my head, but I'll do that and be right back. Push pause. Alright, there you go. Check those answers out. See if they make sense. I hope you tried them on your own first. Okay, next. We have this bad word written backwards case, two angles and one side. AAS or ASA determine exactly one triangle. Two sides and an angle opposite one of its sides, which is SSA, may determine no triangles, one triangle or two triangles. Let's look at it. Like, what did I just say? What does that mean? Consider a triangle in which you are given side A, side B, and angle A. That's side, side, angle. Okay, it's the bad word. By fixing side B and angle A, you can sketch the possible solutions of side A to figure out how many triangles can be formed. In the diagrams below, note that H equals B sine A. So first let's look. What if angle A is obtuse? So I have angle A and side B. I can draw side A up here. I can draw side A all the way down. If side A is less than side B, we have no triangle. If side A is greater than side B, we have one triangle. Okay, this is a case, a possibility. A is obtuse. Side A is less than side B, no triangle. Side A is greater than side B, one triangle. Now what if A is acute? My hypotenuse is greater than side A, no triangle. My hypotenuse is equal to side A, one triangle. If my hypotenuse is less than side A and less than side B, I have two possible triangles. I can have this triangle right here, or I can have the bigger triangle right here. If angle A is greater than angle B, I have one triangle. So when A is acute, I have the possibility of no triangle, one triangle, or two triangles. If A is obtuse, I have the possibility of no triangle or one triangle. Okay, what does this mean? Let's try one. All right, first let's make a sketch. Since A is obtuse and the side opposite angle A is longer than the given adjacent side, you know that only one triangle can be formed. Use the law of sines to find B. Okay, so that last slide you should have jotted down, or you may need to jot down now. So I'm going to sketch this triangle. I've got angle A, B equals 11, side A equals 20. I can use the law of sines to find angle B. Angle B is across from side B, so that is B. So I can say sine B over 11 equals sine A over 20. 20 times sine B Sorry, I should not have written this. I know that's 115. So let's start over. 11 times sine 115 divide by 20. Sine B, still in red, sorry, equals 0.498. Do the inverse sign. Sine -1 of 0.498 equals 29.9 degrees. That is B. Cool? What else can we find? I know that C is going to be equal to 180 minus 115 minus 29.9. So C is 35.1 degrees. I can use the law of sines to find that remaining side now. Sine of 35.1 over C equals, I'm going to use A again, 115 over 20. So I can do 20 times sine 35.1 divided by sine of 115. So that gives me C, the side C, not the angle, is 12.7. Cool, we got them all. That was fun. Okay. Here I left the picture that the book drew. A is acute. And we know that side A is 3.5 and side B is 5. So I need to figure out hypotenuse because I'm not sure what to do here. So the first thing I did here is I drew angle 51 and side of B. I'm going to figure out the hypotenuse. I know the hypotenuse is opposite over hypotenuse. So I can say that sine of 51 equals opposite over this hypotenuse. Goodness, here's my height, not hypotenuse. I hope I haven't been saying hypotenuse the whole time. It's my height. Goodness, I'll have to go back and check. So sine of 51 is opposite over hypotenuse. so I don't know what that is, over b. So 5 times sine 51 equals the height of my triangle, which is 3.9. If I go back and check out that slide from earlier, okay, I pulled it up. If I'm looking, my height is 3.9, so A is smaller. So when height is bigger than A, of course I don't know A yet. Yep, A is 3.5. Sorry, when height is bigger than, when height is bigger than A, so I'm looking at the thing, when height is bigger than A and angle A is acute, it says that there's no triangle. So angle A is acute and my height is bigger than my side A, therefore there is no triangle. Okay, here I left them on 2. I left the drawings that the book provided. Here I have acute and side A and side B. Okay, so I'm not sure, but I can figure out what the height of the triangle is right here. So sine of 40 degrees is opposite over hypotenuse, height over hypotenuse. So 60 times sine 40, 16 times sine 40. So the height is 10.3. So it looks like the height is smaller than A and B. And if I check out that chart, it says that when my height is smaller than A is smaller than B, 2 triangles can be formed. Which is what is drawn here. I have one triangle and another triangle. Those are my possibilities, because both of these have a height of 10.3. Okay, so we need to solve 2 triangles. Okay, for the left triangle, it looks like I need angles B and C. So I'm going to use the law of sines. Sine of 40 over 13 would be sine of B over 16. Cross multiply 16 times sine 40. Divide by 13. Sine B is 0.79. So inverse sine of 0.79 is going to give me my angle B. 52.3 degrees. If I take 180 minus 52.3, minus 40, that gives me 87.7 degrees. So sine of 40 over 13, we just found angle C, so this is angle B. Angle C is 87.7 over C. So 13 times sine 87.7 divide by sine 40. So side C is 20.2. Cool. Let's try that last one. I'm going to work in red to try not to get these things confused. So let's talk about side or angle B. Okay, over here we found that angle B is 52.3 degrees. And that's good. We used the calculator to find that acute angle right here. But that angle B, The obtuse angle has 52.3 as a reference angle, which we learned about this chapter. So its measurement is actually, for the obtuse side, 180 minus 52.3 degrees, which is 127.7 degrees. So B is either 52.3 degrees or 127.7 degrees. So we're good on triangle 1, we finished that, but let's look at triangle 2 to finish that. Angle C, I'm going to have 180 minus A minus B. That gives me angle C as 12.3 degrees. Now if I use sine of 40 over 13, angle C over C, 13 times sine 12.3 divided by sine of 40. It gives me side C of 4.3. Cool, not so bad, huh? All right, some guided practice. So this first one, A, is obtuse. Okay, the second one, A, is acute. All right, so go ahead and try to work through them. Go back to that chart from earlier and see if that helps. I'm going to work through them slowly myself and give you some answers, okay? I'm going to push pause. All right, there's number 3. I did you number 4 on a separate page, so I thought I would show you number 3. The angle is obtuse. A is greater than B, therefore there is one triangle. So here A is acute. So I need to figure out the height of the triangle. And once I know the height, I can use that chart to figure out if there are 2 triangles, 1 triangle, or no triangles. Okay, so it can either look like this. A 9, 12, where I need to look at the height of the triangle. A is 36, so opposite over hypotenuse. Sine 36 equals opposite over hypotenuse. H is height, so 12 times the sine of 36. Height is 7.1. And that chart says that if my height is less than my A is less than my B, there are 2 triangles. So first let's find angle B and then the reference angle and go from there. So I'm going to use the law of sines, but I'm going to push pause and finish solving it. Okay, see if you can solve it on your own. Alright, there we go. We solved 2 triangles. Okay, take a second to check that out. Actually, take your time, make sure you understand it, and we'll move on. Okay, 2 more guided practice. Here I have an acute triangle with 2 sides and an obtuse triangle with 2 sides. Okay, let's look at the height for number 5 to see if it's solvable. Okay, I calculated the height of the triangle the same way I have the past 2 times, and I went back to the chart to look, and it looks like when the height is greater than A, there's no triangle. So we're done with this one. Okay, this last one, I have an obtuse triangle, and it looks like A is smaller than B. So again, we have no triangle. When A is smaller than B, there is no triangle. That's an N. No triangle. All right, another key concept, the area of a triangle. You can use the following result to find the area of a triangle when you know the lengths of 2 sides and the measure of the included angle. This result can also be used to derive the law of sines. So the area of any triangle is given by 1/2 of the product of the lengths of two sides times the sine of their included angle. Right? Included angle means the angle between the two sides. So for this triangle shown, there are 3 ways to calculate the area. 1/2 BC times sine A, because A is in between B and C. 1/2 AC sine B, that is side A and C with sine of B, the angle. Or 1/2 AB sine C. So angle C is between side A and side B. And we're going to start with a word problem. Black-necked stilts are birds that live throughout Florida and surrounding areas, but breed mostly in the triangular region. Find the area of this region. So I have an angle and 2 included sides. So the area is 1/2. The sides, I said included sides, I meant included angle. The sides multiplied by sine of the angle. So the angles between those two sides. That's how you know you can use this law. Just multiplying right now. 1/2 times 223 times 125 times sine of 54.2 gives me an area of 11,304 miles. All right, cool. Okay, try this. The area of triangle ABC with given lengths and included angle. I just need to sketch it really quick. I have I don't remember, I think this is how we've been drawing it. Yeah. C is 46 degrees. A is 10. B is 14. So 1/2 times 14 times 10 times sine of 46. 46 is in between 14 and 10. I have an area of 50.4. A, B, C. Let's see, it gives me angle B, side C, side A. Easy peasy. So 1/2 times 19 times 8 times sine of 75. 73.4 is the area. Square units. I'm not sure how you would say the answers. Okay, push pause on these and then I'll write down the answers. All right, there you go. Next is just 2 slides of the daily homework quiz. I'm going to write down the answers. If you'd like more practice, you can try them. Okay, this first one, I get 2 triangles from this one. To solve it, oh, hold on, my bad. Let me erase this. I was looking at the wrong thing. So, push pause if you want to try it on your own. I'm going to give you the answers though. There we go. Next, push pause. That's an 8. .2. Little c is 13.7. Here, decide if the given measurements, 1 triangle, 2, or none. I have 2 triangles. Here I have no triangles. Again, you might have to calculate the height, the h. two sides of a sports pennant are given. The angle between them is 50 degrees. 1/2 side-side sine angle will give you 124 inches squared. That's it. Good job.